Hello everyone. This video will be addressing the concept of conservation of momentum and what are the conditions in order for momentum to be conserved. So I'm going to start by saying, you know what, F T equals delta P. Okay, this is one of the formulas we talked about in the past. Well, when is momentum conserved? Basically, when is delta P equal to 0? Because delta P is basically final momentum minus initial momentum. So if the force is 0, is basically when the impulse is 0. So if there are no external forces acting on my system as a whole, then the impulse is 0, which means PF minus PI equals 0, which means the final momentum of the whole system equals the initial momentum of the whole system. So the condition is that the impulse, there should be no external impulse. Internal impulses, in other words, interactions between the bodies of the system or the parts of the system are okay because they are internal and they don't exert any external impulse. So that's the condition. So I'm going to do some examples. I'm going to actually show you this by doing some examples. So let's say I have a mass that has a 2 kilogram here, and it's moving this way at 6 meters per second. And there is another mass here that has 4 kilograms, and we'll say maybe it's moving at 1 meter per second. Okay, and we're going to look at different scenarios with this example here. So right before they collide, this is what's happening. So this is before collision, and the collision happens here somewhere. And let's just say after the collision, I'm going to say this one here goes flying to the right. I don't know, I'm going to say 10 meters per second. This is the 4 kilogram one. And I'm going to try to figure out what happened to the 2 kilogram, because the 2 kilogram maybe is still moving to the right at a slower speed than that because it passed some of its momentum to the 4 kilogram, or maybe it bounced back. We don't know. So let's do the conservation of momentum. As long as there are no external forces on my system here, on these two objects, the momentum immediately before the collision and the momentum after the collision should be equal, because maybe later on there is friction, and if there is friction after the collision, momentum is not conserved. But I'm looking at it immediately after and immediately before. Well, I'm going to do the momentum of this. So the momentum of that, so I'm going to call this one 1 and 2, m1 v1 plus m2 v2. That's the total momentum before the collision, equals, well, I'm going to do the momentum after the collision. So after the collision, we say prime. Prime just means after, plus m2 v2 prime. Well, this is going to be 2 times 6 plus the mass is 4 times 1 equals 2 times, well, we don't know what the speed of this guy is. That's what we're looking for, plus 4 times 10. Now, if we do the math here, this is what? This is 12, and that's 16 equals 2 v1 prime plus 40. So v1 prime is going to be equal 16 minus 40. That should be negative 24 divided by 2, so negative 12. Okay, which actually means that after the collision, this 2 kilograms is going to have a speed of 12 meters per second, but negative, which means it's going to bounce back. If the value turned out to be positive, it just means that it's going to continue in that direction. All right, so let's look at another example. Okay, so this time, what I'm going to do is that I'm going to make this guy here go in this direction at, I'll keep 1 meter per second. Right? And after the collision, maybe it just goes flying to the right at 5 meters per second. So I'm starting with 2 objects here. I'm ending up with 2 objects here. I should have 2 terms and 2 terms for the equations. So this is, again, it's 2 times 6 plus 4 times 1 equals 2 times v1 prime plus 4 times 5. But if you look, pay attention here, this one here is pointing to the left. So I have to make that negative. That's important. So this should be minus. Okay? The 5 kilogram bounced back, so which means it's a positive 5. It didn't just keep going this way. And let's see what happens. So it's 12 minus 4 equals 2 v1 prime plus 20. Well, this looks like it's, what is it? 8 minus 20, negative 12 equals 2 v1 prime, which means v1 prime is equal to negative 6 meters per second. So again, in this case, also this one bounced back. If it had a positive speed, it will mean that it continue to the right. Well, what else? Let's do an example where they collide and they stick together. So, and I'm going to leave it like that. And I'm going to try to find the speed of the combination. So here is the 4 kilogram here. So this holds, but here it looks like I have just one object with a mass of 6 kilograms. And I can call it V12 or just V prime. Okay, so this one is going to be 2 times 6. Here I started with 2. I have 2 terms. Here I ended up with 1. I have 1 term. Plus 4 times negative 1 equals 6 times V prime. And we have no idea which way it's going to end up going. But I think by looking at the numbers, this is a 12, this is a negative 4. This has more momentum. I think so it's going to influence the outcome. So I think we should end up going to the right, conceptually. So this is 12 minus 4 equals 6 times V prime. So this is 8. So this is 8 divided by 6. So V prime is 8 divided by 6 meters per second, which means it's positive, which means the whole thing is going to go right. I think I should do one last example where I have 2 objects attached to each other. Okay, I'll keep the same thing. Okay, and they're both moving to the right, maybe at 2, let's say 12 meters per second. I'm just making up these numbers. Okay, so and I'm going to say this one here, let's say there is an internal explosion. In other words, they're going to separate. There is like a spring between them or something that I can remotely activate. And it's just going to, as they move in, they're going to separate. So I'm going to say the 4 kilogram, I don't know, moves that way at 20 meters per second. So let's figure out what happens to the 2 kilogram mass. We don't know what happened to it. Well, here I started with 1 term. Okay? I'm just going to call this V. There is no reason to put subscripts here. Equals M1 V1 prime plus M2 V2 prime. Well, here it looks like this is 6 times 12 equals, this is 2. Well, I don't know the speed of this guy. Plus, then I have 4, 20 to the right, which means it's a positive 20. So this is 72 equals 2 V1 prime plus 80. So this is going to be V1 prime. Looks like it's negative 4 meters per second, which means this 2 kilogram bounces. It doesn't necessarily mean that it's going to bounce at all times. So I'll show you an example where maybe it doesn't bounce. So I'm going to make this maybe 15. Yeah. So if I put a 15 here, so this becomes 60, right? And this becomes 6 meters per second. So after the explosion, this one continued to the right. It's just at a slower speed. Okay? And that should do it for the conservation of momentum. And we're going to do some more examples in class, okay? So I'll see you later, guys. You take care. Bye-bye.